Okay, so in review question 15, we have a context of two point charges, and we're asked to draw the electric field as representative of the electric field created by both charges. So it's two positive charges, and one has twice the charge of the other. So before we get to draw the diagram, things I should probably know at the beginning is that the number of field lines that emanate from a charge is proportional to the size of the charge. So the number of field lines I draw out from the plus 2q should be twice the number that drawn out of the let's say plus 2q should be twice the number of field lines out of this plus 2q as there is out of the plus q. And I say draw out, that's the second rule, in the sense that the field lines are drawn away from positive charges. So I want to sort of be thinking about that the couple of rules here. So the number of lines is proportional to the magnitude of the charge. Field lines are drawn away from positive charges. So if there were negative charges, I would draw them towards. And now I want to think also for the situation, where are these sort of symmetry in the, is there any symmetry in the diagram? So for this problem, if they're both the same size charge, the field would be 0 right in the middle between the two. But it's somewhat awkward. The field will not be 0 in the middle. So I want to figure out at what point is the field 0 and sort of draw my lines sort of up towards that sort of line which sort of would give us a field of 0. Now figuring out where the field is 0 is a little bit challenging. There's a couple of ways you could do this somewhat qualitatively and state that since this charge is twice the charge and the electric field, so I know the field is kq over r squared. Since I have twice the charge, I need to have root r of the distance. Sorry, root 2 of r of the distance. So the away from the plus 2q should be root 2 of the distance from the point of 0 electric field than that of the plus q. So you can do that ratio if you were comfortable with that ratio. If you wanted to do something that was more quantitative, you could. So maybe I'll write this down. Since plus 2q is equal to 2 times the q, the r of the 2q has to be root 2 of the r for the q. So that's sort of what I was trying to say earlier. But if you wanted to prove that to yourself, you could. So I'll do some of the math here, which may be helpful for other problems. And I'll just zoom in here for this problem, this part of the problem. So let's say the field is 0 between the two charges. The field cannot be 0 at any other point, because if it's over at this point, it's away from the plus q, away from the plus 2q. Any point to the right of the plus 2q, again the field points away from the plus 2q, away from the plus q. So it's somewhere here in the middle where the fields are opposite direction. It's going to be closer to the plus q than it is for the plus 2q. So let's say that we have some point x where the field is equal to 0, where Ex equals to 0. And let's say the charges are separated by a distance d. So that means that we can call it, let's say this is a distance x from the plus q, and then from the 2q we've got a d minus x, which is going to end up here with a quadratic. So we can say that the fields at x to be 0, that means the field at x, the field due to the plus q divided by x squared, that's the field due to the plus q, has to be equal to the field due to the 2q divided by dx, all to be squared. So we can cancel out the k's, we can cancel out the q's. So I end up with d minus x all to be squared equals 2x squared. And this will leave me with d squared minus 2 dx plus x squared equals 2x squared. I'll write this in the form of the quadratic, bring everything over to the right hand side. I'll be left with 2x squared minus x squared leaves me with x squared plus 2 dx minus d squared. And if you solve that quadratic, x will be equal to 3.7. Oh, sorry, I jumped a step here. D in this case, if I count out the number of boxes, 1, 2, 3, 4, 5, 6, 7, 8, 9, is 9 boxes. So if I plug in 9 units for D, I get x to be 3.7. And that means that the 3.7 boxes from the Q charge, which means that we're if we subtract the 3.7 from the 9, 3.7 exactly, we should end up with 5.3 for the other ones. And so if we're at 1, 2, 3 around here, this is our point where our field is 0. That's 3.7 boxes from the plus Q, 5.3 boxes from the plus 2Q, and 5.3 is equal to root 2 of 3.7. So that's sort of come back to my original point, that the distance away from the plus 2Q has to be root 2 times the distance away from the plus Q for the field to be 0. Okay. So that's that piece. So I sort of want my field lines to sort of be moving up sort of towards this particular point here for the 2Q, and sort of spreading outwards for the plus Q, and then I want the number of field lines for the plus 2Q to be twice that for the plus Q. So okay, so what I'm going to do here, I'm going to try to pick a number of lines that are easy numbers to pick. So what I'll do is I'll draw 8 lines out of the plus Q, and I'll draw 16 lines out of the plus 2Q. So I can start here with this line, the lines here, and sort of they're emanating away. The field, in a sense, would radially point out from the charges, if the charges were just single charges. So I'll do my best to draw this accurately, but I can't. It's difficult to draw exactly the exact field without determining the field at every single point, the vector quantity, and then drawing the field line tangent to that quantity. So this is somewhat qualitative from this point onwards. Alright, so draw one here. Symmetry here. I think I have messed up my symmetry. It makes this somewhat challenging. So I wanted to have symmetry in the problem. And I've left myself with 7 lines. 1, 2, 3, 4, 5, 6, 7. So I might just switch my rules here, and I'll draw 14 emanating from the plus 2 cube to sort of fix my problem. So we're going to keep track of the number. 1, 2. Something on this order. So going back to the beginning of the question, if I were to look at the number of felines 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So the number of felines that are emanating from each charge are proportional to the charge. I have drawn the felines away from the both positive charges, which is by convention. I have located where the this field is sort of roughly 0. Certainly 0 right smack here in the middle. Every other point you have to do a vector sum. So sort of around this line is sort of where my field is 0, which is not halfway between the two charges, which it can't be because the charges are unequal. Again, indicating that the density of the felines is it should be more density factor around the charges, and it's a qualitative diagram. It says sort of the key qualitative features for this particular diagram.